right, guys, so let's get this out of the way. Sorry. Okay, here we go. So we're starting with number 13. So you're trying to show if these two trapezoids are congruent, and the way that you are going to do that is you are going to map A, B, C, D onto, what is it, E, F, G, H. Okay, so you got to make them be on top of each other. So you're going to go through all of these options, A, B, C, and D, and you're going to check. Now, you can check and see, like A, B is 2, so E, H, or E, F is also 2. B, C is 3, G, F is 3, D, C is 1, H, G is also 1. Like, they are congruent, so D should be out. Okay, so then let's go through and try to figure out which one is. So part A, or answer choice A, says they are congruent by reflection, I should say over the line y equals x. So remember, y equals x is a slanted line. You start at 0 and your slope is 1 over 1. So 0 up 1 over 1. You have notes on this in your binder. I forget what color they are, but they're reflections. All right, so the way that you reflect to this line, you can count across 1, 2 to the line, like directly across, and then you would go 1, 2 from the line, because reflections are all about distances from the line. So this is where C would go, and C matches up with G, and we know those two don't match. So that's one way you could do it. You could also, I count to the line, so I know that it's 1, 2, 3, 4 spaces horizontally from the line, and the way that it's going to flip over is if you go 1, 2, 3, 4 spaces down, okay, and then you cross over that line. So that is where C prime is, which is where G should be. So since they don't map up there, then A has to be out, okay? So then, let's see. So we know A is out, we know D is out. So let's look at B. It says, yes, they're congruent by a 180-degree rotation about the origin, and then a reflection in over, I don't know why they keep using in, over the line x equals 4.5. So first things first is the 180-degree rotation. About the origin, you take your original point and you make them both opposite. So you keep them in the same order and you just make them both opposite. So you can do this pretty easily. A is negative 6, 3. And so A prime, or where does A go? A should be E, goes to positive 6, negative 3. So positive 6, negative 3. Okay, so that's where A prime goes. Now, no, it doesn't match, but remember you have something else to do. Okay, so go ahead and rotate it first and then reflect it to see if it matched. You can't cancel it out first. On the first one, there was nothing after the reflection, so we knew it was automatically out. Okay, so then you have B, which is at negative 6, 1, would rotate to positive 6, negative 1, positive 6, negative 1. So B prime's there, and you can do it for all of them. So then you have, let's see, that's A and B. Sorry, guys. All right, so you have A here, A prime, B prime is here. And then let's see, C is negative 3, 1. So it's going to rotate 3, negative 1, 3, negative 1. So that's C prime. And then D is negative 3, 2. And then it's going to rotate to be 3, negative 2. Negative 2. Okay, so, oh, something's wrong. Oh, whoops. Negative 2. So this is what you get originally, okay? Then it says reflected across x equals 4.5. If you go to your very first set of notes, they're yellow. It talks to you how to how to graph these points. This is everywhere that x equals 4.5. So it's actually a vertical line on 4.5, which is right here. And so if you flip all of these over, A is going to go to E, B is going to go to F, D is going to go to H, C is going to go to G. And so they do match up perfectly for that answer choice. If you translate and then reflect over the y-axis, reflecting over the y-axis is going to keep it looking like this, and we need it to flip over, so that's not going to work. Okay, so that's why B is your answer choice. All right, so that's number 13. Number 14 was kind of tough. The first part was, there's some parts in it that should have been really easy, like the very end should have been very easy, like your last 3 answer choices, maybe last 4, but your first 2 were a little tough, so we're going to go over those 2. So first things first, some of you didn't write down what you're given. Please write down what you're given and plot it on, like draw it if you have to. So it tells you AC is congruent to FG, CB is congruent to GE, and C is congruent to G. So if you go to the very last one, which is like I couldn't get in the same slide, you are proving these triangles are congruent by side, angle, side. That's what, like that gives you, that is given to you in that. Okay, don't miss that part. Then, actually I changed my mind. Let's jump to the bottom. These parts right here are super easy because it tells you C maps to, well, where does C have to go to? C has to match with G, and AC has to match with GF. Like that is a given. Once again, they give that information to you in the very top part up there. Okay, so then the other part is a little weird. This one isn't that bad. Think about if you translate it, AC is on the left, and it's still going to be on the left. We need to get it to the right, okay? So it can't be, you can't use a translation to get it there. A rotation, if you spin this shape, A is going to spin, or C is going to spin down, and A is going to be up, and we need C to be up at the top with G. So a rotation is not going to work. The only way you're going to get this ABC to match with EFG is if you flip it. So you are going to have to reflect it, and let's see how that works. So to begin with, it asks you to translate. This is the really hard part. I probably would have struggled with this if I didn't see the key. Everything's going to overlap unless you take B and match it up with E. Then you somehow kind of have this triangle that looks like this. Then you can flip over and you can have C match up with G. So you want to translate B to E, then you want to flip it and all your parts match. All right, then we have number 15. Okay, so it says, Matthias and Constant were discussing the triangle shown and how to prove them congruent by side, angle, side. All right, so you're given that AB is congruent to DE. You're given that BC is congruent to EF, and B is congruent to E. Okay, so somehow you need to transform ABC so it's on top of and matches up with EFG or DEF. All right, so it's asking which transformations. All right, so you have a rotation of 90 degrees about point C, a rotation of 180. You have all of these. So instead of going through all of this, it's going to take a long time. So the answer is C, and let's talk about why. So if you take this and you slide it, C over to F, you're just literally sliding it straight across. So then you have, let's see, something like this. So you have, it should look like that. And then what's to a rotation about point C. So here's point C still. And then you want to rotate it 180 degrees. So that's going to allow B to match up with E. Okay, so that is how that works. So you're going to translate and then you're going to rotate. Okay. Number 16. Okay, so it tells you that angle A, well, if you're looking at these triangles and you're trying to prove them congruent, you know A is the angle between the 1 bar and the 2 bars, so the only angle that matches up there is D, and so you just have to make sure you read them correctly. This angle is equal to BDC, because remember, it's the vertice that's in the center. Angle ABC, so be careful here, ABC, A to B to C is that angle right there. That is the angle, and if you want to add these, if you want to add the 3 lines, this angle is the one between the 2 and the 3 sides. So this angle is going to end up matching with this angle down here, because remember, it has to be the angle that's between the same side. So the B angle is between the 2 and the 3 sides, so then this angle matches between the 2 and the 3 sides. And I mean the bars on the, so you're talking about DCB, because it's the only vertice that has a C. And then, do different color, and then it says triangle AC, or angle, my bad, ACB. That means that this angle must be congruent to this one. So you're looking for the one with B as the vertice in the center, which is DCB. Okay, 17. It's kind of hard to put 17 here, but it says complete the proof. Here, actually, I'll do this. Here's your proof. And I'll draw the picture really quick. Okay, so there's the proof. And your picture looks like this. You have A, D, E, B, and C. All right, so it tells you, don't forget your givens. Some of you are forgetting your givens, okay? You have, that's the easy part. AB is congruent to CD. And then it tells you that AD is parallel to EC, okay? And you're trying to prove that EBA, this angle right here, is supplementary to CAD, this angle right here. And most of this proof wasn't too terribly bad. Okay, so let's look at the beginning. It gives you your 2 givens, and then it says if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So what it's saying, this is talking about an isosceles triangle. If you have these 2 sides that are the same, that means their base angles must be the same. So your answer choice here should be B. It tells you that angle ABC must be congruent to angle ACB. Okay, so then it says, how do you know? So then your next line is asking you, how do you know that ACB, this angle right here, is congruent to CAD? Well, remember, you're given parallel lines. So you have these 2 parallel lines and you have this transversal, and those are alternate interior angles. So your answer choice here is G, alternate interior angles. All right, so then the transitive property. A lot of people forgot the transitive property. They're in your notes. They're somewhere, if you're in first period, they are somewhere in, I think they're bright orange in your proofs cheat sheet. And then if you're in first and second period, there's some, or second and third period, they're somewhere in, they're blue or green at the very beginning with all your proof stuff. You definitely have, I think it's a blue sheet. So the transitive property says, if you have something is congruent to something else, and then that same thing is congruent to something different, you can take out these middle parts and you know A is then congruent to C. So that is what you have here. You can take out the AC and the AC, so then you have angle ABC is congruent to angle CAD, and that is option C. And then it tells you that EBA, this angle right here, and ABC, this angle right here, are supplementary, and we know that because it is a linear pair. So this should be I, because they form a linear pair. That proof really wasn't too bad. I think most of you got it right. All right, then this proof. Again, most of you got this one right, and let's just make sure you understand why. So once again, you're given, make sure you draw this picture on your EOC. Everything's online, so draw them. ABC, or my bad, AB is congruent to BC, and angle 1 is congruent to angle 3. All right, so you're trying to prove that L is parallel to M. So you have your two givens, and then you have 1 is congruent to 2. And once again, this is the idea of isosceles triangles. Okay, if you have two sides that are the same, your two base angles have to be the same, and then that option would be B. When two sides of a triangle are congruent, the angles opposite of those sides, so that angle and that angle, must also be congruent. Then it says, then you have angle 2 is congruent to angle 3. You cannot use alternate interior angles here because you do not already know that those lines are parallel. However, if you take this idea and look up to those two, they kind of wrote it pretty crappy. I wish they would have wrote angle 2 is congruent to angle 1, and then angle 1 is congruent to angle 3. But you share that, and so that means your first and your last are congruent to each other. So this should be your transitive property, which is F. And then last but not least, now that you know that this angle is congruent to that angle, it's the converse of the alternate interior angles, which says if alternate interior angles are congruent, then you know that the lines are parallel. And so that is G. When two lines are cut by a transversal and alternate interior angles are congruent, the lines are parallel. Okay. Number 19 is this guy right here. Okay, so first things first, some people miss this. Make sure you go through and plug in those values. So X is 15. 15 plus 50 was at 65, so that makes this 65. And then up here, you have 3 times 15 is 45. 45 and 25, I can't think right now. 45, 25 is 70. So this angle is 70, and then they tell you y is 60, so that's 120 minus 5, this is 115. Okay, so they give you your angle measures. Then you have to figure out which sides of these are parallel based on those angle measures. So you have A, B is parallel to CD because alternate interior angles are congruent. Well, if you're talking about these angles, you would assume be talking about this transversal, and 70 is not equal to 65. So this one is out. Okay, the next one, AD. So now you're flipping your parallel sides. So now they're giving you AD and BC are parallel because alternate interior angles are supplementary. Okay, for problem, alternate interior angles should be congruent. So this statement is just wrong. Okay, The next one, AB is parallel to CD because consecutive interior angles are congruent. Well, once again, this is written incorrectly. Consecutive, the one after the other, these should be supplementary if they're parallel. So again, that one's out. So really your only answer choice is D, and let's see why it works. So it says that AD is parallel to CB because consecutive interior angles are supplementary. So we're looking at this transversal, and then when it says consecutive, it means one right after the other. So those two interior angles, and then 115 plus 65 is equal to 180, which is supplementary. So that's why D is the answer. Okay, here, this one isn't too terribly bad. What number is this, 20? It's a little confusing in like the wording, but hopefully most of you figured it out. Okay, so given you have point P, and then you have PA is congruent to PB. Then we get down to here, draw the line M through point P. They did that. As a perpendicular bisector, we need to understand what that means, okay? So obviously perpendicular means right angle. Bisector means we're splitting in half. So if this is a perpendicular bisector, that means it is splitting that line into two equal parts, and it split AB in half. Because it's given that PA is equal to PB, and APB, so they're talking about the whole triangle, is okay, based on what they gave us, we know that this side and this side are the same. This side, we have no idea what the final measurement is. We just know that it's split in half. So we can't say it's equilateral. It has to be isosceles. Isosceles is two sides. Equilateral is all three sides. Scalene means none of them are the same. So then it says M is the bisector of, well, the only line that could possibly be splitting anything in half, M is splitting P in half. That's the only way. It doesn't touch A or B, so it has to be P. Because the perpendicular bisector of the base is the same line as the bisector of the vertex angle, therefore blank is on the perpendicular bisector. Once again, the only angle that's on that perpendicular bisector is P. Okay, guys, the bell is about to ring soon for 5th period, so this is going to be the last problem I do on this video, but I will quickly go through the rest on another video. I'll just upload it later. Okay, here. So once again, they're telling you some important things. They're telling you that these triangles are congruent. That means these overlapping triangles. And if triangles are congruent, that means all of their parts are congruent. All three corresponding sides and all three corresponding angles. So when they tell you that A is 45 degrees, that means D is also 45 degrees. Then they tell you that ABC, that whole angle is 3x. Then they tell you that DBC, this little guy right here, this part of 3x is 30 degrees. And then they say ACB, this little angle right here, is 4y plus 2. So if I were you, I would solve for y first, because I know that these two little angles right here are both the same in those triangles, okay? So, you know, 4y plus 2 is equal to 30, and you can solve for that, okay? So then you have x. So you have this angle right here, and then you know this angle is 30. So when you're looking at this, you need to look at the whole triangle, and then you know that 45, because you know all triangles, all three angles add up to 180. So 45 plus the angle 3x plus 30 is all equal to 180. And then that's how you're going to solve for x. Yeah, okay. That's it for right this second. I'll try to get this uploaded soon, and then I will finish those in a second. or I will finish those other ones soon. All right.